I'm Anil Kumar sharing with you previous test paper on exponential and logarithmic functions. This is a very scoring unit and I hope and wish that all of you get at least 90% marks in this particular test. It will help to boost your average. All the questions which I have taken are from the test papers, so seriously looking into them will help you perform better. I have divided this test in two parts. In part 1, we'll take up exponential and logarithmic equations. Some of the questions are based on change of base formula. As you can see here, question number 1 to 4. You can always pause the video, copy these questions. Then in part 2, we'll take up application questions on exponential and logarithmic functions. So here are question number 5 to 9. You can pause the video, copy these questions. I think now question number 8 and 9 are clearly visible to you. Now let's begin and solve this test paper. I'll explain you the concepts as we move along. Normally this test paper will take around 45 minutes. Question number 1 is, we need to solve the equation, means find the value of x. 9 to the power of 2x plus 1 equals to 81 times 27 to the power of x. The idea is to write them with same base. So we are looking for a common base here. That is a strategy. Clearly the common base is 3. So I could write 9 as 3 square. I could write 9 as 3 square. And what we have here is 9 to the power of 2x plus 1. So I'll write this as 3 square 2x plus 1. On the right side, I have 81 27 to the power of x. So 81, we could write this as 9 square also. Anyway, so we'll keep number 81 as such for the time being. 27 to the power of x, 27 is 3 cube. So that we'll write as 3 cube to the power of x. Is that clear? Now, since we have the same base, we can combine the x terms. There are some constant terms here, as you will realize. If I open this bracket, what do I get? This 2 gets multiplied by 2x plus 2, right? So here we get 3 to the power of 2 times 2, 4x, plus 2 times 1 as 2. And here we have 81 times 3 to the power of 3x. Now, we could apply the exponential laws. That means product, right? So we have 3 to the power of 4x times 3 square, which is 9, right, equals to 81, 3 to the power of 3x. Now let's divide by 3 square, which is 9, this number 81, and bring 3 to the power of 3x on the left side. So we have 3 to the power of 4x divided by 3 to the power of 3x. And on the right side, we have 81 divided by 3 square. I know some of you could have just divided by 9 and got 9 here, which is 9, right? So on the right side, we get 81 over 9. On the left side, it is 3x. 4x minus 3x is just x. So on the left side, we get 3 to the power of 4x minus 3x. And on the right side, we are getting 81 over 9, which is 9. Also, you could write this as 3 square, right? Now, 4x minus 3x is x. So we have 3 to the power of x as equals to 3 square. And that gives you that x is equal to 2, right? So comparing the exponents, we get x equals to 2. So I've actually taken more steps than usual to solve this particular question. The idea is I'm just showing you how to move around with these numbers, right? So the answer here is x is equal to 2. Let's do the next one. We have 4 to the power of x plus 3 minus 4 to the power of x equals to 63. Now, I'm going to adopt a different method to solve this particular question. Means these steps which I'm following now for part B are more efficient. When I say 4 to the power of x plus 3, it means it is 4 to the power of x times 4 cubed, right? Minus 4 to the power of x equals to 63. Now, we could take 4 to the power of x common. So if I take 4 to the power of x common, I get 4 cubed minus 1 equals to 63. Now 4 cube is what? 4 times 4, 16. 16 times 4 is 64. So we get 4 to the power of x as 64 minus 1 equals to 63, which is 63, right? So we get 4 to the power of x times 63 equals to 63. Divide by 63, 4 to the power of x equals to 1. Now what should be the value of x? We know 4 to the power of 0 is 1, right? So we can say x is equals to 0, right? X equals to 0 gives you the solution. So in this particular case, the solution is x equals to 0. Anything to the power of 0 is 1. Perfect. So we know that b to the power of 0 is actually 1. So if there is 1 here, the exponent should be 0, right? So let's take up question number 1c, which is 5 to the power of 2x minus 5 to the power of x equals to 20. Now this is different from the previous question in a way that we have a quadratic equation here. Do you see that? Let me rewrite. 5 to the power of 2x minus 5 to the power of x minus 20 equals to 0. Let me substitute like this. Let 5 to the power of x be equal to, let's say, p. In that case, I could write this equation as p square minus p minus 20 equals to 0. So I hope you notice it's a quadratic equation, which we can now factor. 5 times 4 is 20. We need negative, so negative 5 times positive 4 equals to 20. That gives you two solutions, p equals to 5 or p equals to minus 4. Now p is 5 to the power of x. So we have 5 to the power of x equals to 5, which is like 5 to the power of 1. And we also have 5 to the power of x equals to negative 4. As you know, negative 4, no solution, right? This is no solution. However, here we have a solution, which is x equals to 1. So we get one solution in this case, which is x equals to 1. The last question, part D, is very different from previous two. The idea is to give you a variety. 6 to the power of 3x plus 1 equals to 25. We could write this as 6 to the power of 3x times 6 to the power of 1 equals to 25. That basically is 6 to the power of 3x equals to 25 over 6. Now we do not have common base. How should we solve this one? So we need to take log on both sides. On both sides to solve it further. Now this is very critical step. So we say log of 6 to the power of 3x equals to log of 25 over 6. Now using the properties of logarithms, we get 3x into log of 6 equals to log of 25 over 6. So from here we can find what x is. So x is equals to log of 25 over 6 divided by 3 times log of 6. Do you see that? That is the value of x which we need to calculate. So let me get hold of the calculator to figure this out. You can always pause the video, find the answer, check with my solution. So what we get here is log of, within brackets, 25 we have divided by 6. So I put two brackets here, divided by, within brackets we'll write 3 times log of 0.6, and that is equal to 0.26549. So that becomes the solution for the given question. At times you may like to round it to 3 decimal places. So we could write this as approximately x is equals to 0.265. Correct. So I hope this first question is absolutely clear. We took up 4 different equations. They were all of different types, and this is just to provide you with the variety which you can expect in a test paper. Let's move on to question number 2. Question number 2, we are solving part A. We need to solve for log 5th root of x squared minus 21x equals to 2 over 5. Remember, in logarithmic equations, you could have extraneous roots. Let me rewrite this question. We have log 5th root of x squared minus 21x equals to 2 over 5. So 5th root means, let's rewrite like this. Log, the base is 10, x squared minus 21x, and we have here power of 1 over 5 equals to 2 over 5. 1 over 5, using the power rule, I could write as 1 over 5 log of x squared minus 21x, and that is equals to 2 over 5. Now multiplying both sides by 5, we could always cancel 5, correct? So this gets cancelled off. So what we get here is log of x squared minus 21x equals to 2. Now we'll convert the form to exponential form. So base is 10 here, so we could write this as x squared minus 21x equals to 10 square, which is indeed 100, right? Now bringing 100 to the left side, we get x squared minus 21x minus 100 equals to 0. This is a quadratic equation which we can factor and then solve. So let me rewrite this equation here. X squared minus 21x minus 100 equals to 0. 100, 24 times 25 times 4 will work, right? 25 times 4. So we could write this as x minus 25 times x plus 4. So when you multiply, you get minus 100. When you add them, you get minus 21. And that gives you 2 solutions. One is x equals to 25, and the other one is x equals to minus 4. So these are the 2 possible solutions for x. Now it's it's very ideal to really check it out using calculator, correct? So let's use the calculator to check the solution. So what we have here is, we'll do log of 5th root. So we have log. Another alternative which I should tell you is, you should find the domain of this function also. So let's kind of extend this question. Well, since the root is 5th root, right, we have to find the domain, because for negative we have a negative answer. So let me find the domain. So we have x squared minus 21x, which could be written as x times x minus 21, correct? So this is basically a parabola where the graph will be like this. One root is there, one root is there, right? So what we notice here is that this point here is 0, this point here is 21. So anything which is on the left side of 0 and on the right side of 21 is in our domain, right? So basically for this function, the domain of this function is x belongs to real numbers, where x is either less than 0 or x is greater than 21. You get an idea, right? Only then, since both our roots are within the domain, our answer is correct. So we write our answer as x equals to 25 and x equals to -4. What you should do is also check using calculator. Is it okay? You will get it correct since it is within our domain, right? So I hope that makes sense. Let's take part B of question number 2, which is log to the base 5 of 2x plus 2 minus log to the base 5 of x minus 1 equals to log to the base of 5x plus 1. So let's combine all these terms. What we basically get is, let me first rewrite all in one side. We have 2x plus 2 minus log x minus 1 to the base 5 minus to the base 5 log of x plus 1 equals to 0. So that basically, using the logarithm laws, we get 2x, which is x plus 1, I could factor, right, plus 1, divided by x minus 1 times x plus 1, correct, equals to 0. Now here x plus 1 cancels. So what we have here is log of 5, 2 over x minus 1 equals to 0. That means 2 over x minus 1 is equals to 5 over 0, which is 1. So we'll cross multiply, getting 2 equals to x minus 1. Now from here, we can solve that x is equals to 3, right? So this implies x is equals to 2 plus 1, which is 3. So that becomes the solution for the given equation. So what you should do here is that you should plug in 3 here and then check your answer. Is it okay? So that would be a good idea to check the answer for x equals to 3. Right. So I'll leave this also for you. Now how do I check it? I actually find the restrictions. So this gives us that x should be greater than what? It has to be positive, right? So which is, if I divide by 2, it is 1. So it has to be greater than minus 1. This tells you that x should be greater than 1. This tells you that x should be greater than minus 1. So x greater than 1 is our domain, right? So let me write down here that we are looking for x greater than 1. Now since this is greater than 1, since x is greater than 1 and 3 is the correct answer, you get an idea, right? So we should check with the domain. Question number 3 is a communication question. We need to prove the change of base formula. Log a base a x equals to log of x divided by log of a. Explain its importance to determine value of log to the base 2 of 3. So let's begin with log to the base a of x. We want to change the base to 10, correct? Now what we can do here is, let us say log to the base a of x is something equal to p, right? So now we can change the form to exponential form. So change to exponential form. That is how we also solve equations, right? So we get x is equals to a to the power of p. Does make sense? So x becomes equal to a to the power of p. Now, you want to really change the base. So to change the base, what we can do is we can take logarithms again, right? So now we'll take log, both sides. So I'm taking log to the base 10 since I need that, right? So we get log of x equals to log of a to the power of p, correct? So we have log of x equals to, now applying the power rule, we get p times log to the base 10 of a. So what is p equals to here? P will be equals to log of x divided by log of a, right? That is p. So p basically was log to the base a of x, correct? Which is log to the base a of x, correct? This is what p is. This is how we defined it, right? And now what are we saying? By taking the logarithms again, we have shown that this particular expression, log to the base a of x, could be written as the ratio of any other base. In this case, we have taken base as 10 of log of a. Does make sense, correct? So that is how you can prove it. Now part B here is to explain its importance. To find the value of log to the base 2 of 3. Now let me share my calculator. Now most students will not have this function where we could write down the base. Normally you have log to the base 10 or ln, correct? I have this function log, which is kind of like this. Do you see that? So I have this particular function which could be utilized to calculate this value. However, normally it is not there. So what we do here is we change the base. So we can write this expression as log to the base 10 of 3 divided by log to the base 10 of 2. And now you can evaluate the value. So we have log of 3 and then we can divide this by log of 2 to get the answer, which in this case is 1.5849, correct? So which you could round to 1.585. So without changing the base, it becomes very difficult to find the value of logarithms. That's the whole idea. So I hope that helps. Let's move on. We have a very interesting question, which is if log 4 to the base 4 of 16 is x plus 2y and log of 0.0001 is x minus y, find x and y. Now that's a thinking question. We are given two equations. One is log to the base 4 of 16 equals to x plus 2y. Now this equation, we could write this as log to the base 4. 16 is 4 square, right? Equals to x plus 2y. Now that means it is 2. So we get 2 equals to x plus 2y. Now that becomes one of the equations, right? Now let's do the other one, which is log 0.1231 equals to x minus y. Now that basically means log 10 to the power of 1, 2, 3, 4, right? So to get it to 1, we have to do 1, 2, 3, 4. So minus 4, right? That is how we are going to write this as x minus y. Now this is base 10 and therefore we have minus 4 equals to x minus y. So we have two equations. Let me call this as our equation 1. This is equation number 2. We can do elimination or substitution to figure out our answer. So let's do elimination. So what we will do is we'll do equation 1 minus equation 2. So when I do this minus this, I get 2 minus 4 means 6, right? So we get 6 equals to x minus x is 0. 2y minus y gives us 3y. And that gives you y equals to 6 over 3, which is 2. Now since y is 2, substituting 2 here, we could get the value of x, correct? Or there. So from here we could also write x is equals to y minus 4. So since y equals to 2, x is equals to, x is y minus 4, which is 2 minus 4. So x value is equals to minus 2. So we get our solutions. We can write down the answer as x equals to minus 2 and y equals to 2, right? So that is how you would actually solve this particular question. So I hope the steps are absolutely clear. Feel free to write your comments and share your views. Let's move on and take up the next question. Now these are the application questions which we are going to take in part 2. So I hope you find part 1 interesting and useful. So in this particular set, what we did is that we solved few questions which were solving equations like this. So I hope all these solutions are absolutely clear. And now in part 2, we'll take up these questions from 5 to 9.